Take a moment to read the question. The sum of an infinite geometric series of real numbers is 14 and the sum of their cubes is 392. We have to find out the first term of this series. How do we do this question? Let us assume that the first term of the GP is A and the common ratio is equal to R. Therefore, from the given conditions, we have A divided by 1 minus R is equal to 14. So A divided by 1 minus R is the sum of the GP up to infinity, and R here is less than 1 in magnitude. When we cube the terms of the GP, we get another infinite GP whose first term is A cubed and whose common ratio is R cubed. Therefore, we have the condition that A cubed divided by 1 minus R cubed is equal to 392. From the first equation, we get that A is equal to 14 times 1 minus R. From the second equation, we get A cubed is equal to 392 times 1 minus R cubed. When we cube the first equation, we get A cubed is equal to 14 cubed times 1 minus R whole cubed. Comparing this with equation 2, we get this equation, which can be rewritten in this form. Now the right hand side here can be factored in this form, and therefore the overall equation can be simplified and written down like this. We can now cross multiply to get this equation. When we take the terms to the left hand side, we have a quadratic equation in R. On dividing by 3, we get this. We can now split the middle term to get this. We can group the terms on the left hand side. So the left hand side has been factored in this form. From this equation, we find that the two possible values of R are half and 2. Now R, being the common ratio, must be less than 1, and therefore we reject the second value. We can now find A from this equation. So A is equal to 14 times 1 minus half, which is equal to 7, and therefore the correct answer is option C.